So double the angle, we have sine 2 alpha, that's again common one, is 2 sine alpha cosine alpha. The other one is cosine 2 alpha, and this has actually 3 of them. You'll see why 3. Let me take you back to maybe section 20.1. We said sine square plus cosine square equals what? Yep. And if you want, you can solve for sine squared. What is sine squared equal to?
1 minus cosine squared.
Yep. And if you want to solve for cosine squared, what's cosine squared x equals to?
1 minus x.
Where the other two come from, if you do that substitution, if you take the cosine squared, now replace it with 1 minus sine squared. So you'll have, in place of cosine squared, let's put 1 minus sine squared. And there's the minus sine squared. Well, they're using alpha here. We use alpha. So what will happen to that equation? It becomes 1 minus, how many of these? 2 of them. See that? That's one of the equations in the book there. The other one, the same thing. If you go back, cosine 2 alpha equals cosine squared alpha minus sine squared alpha. If you replace sine squared with what? 1 minus cosine squared, so you'll have cosine squared alpha minus 1 minus cosine squared alpha. It's going to make that a minus, going to make that a plus. See it? Plus. So what's a cosine squared plus a cosine squared? 2 cosine squared alpha minus 1. So that's why it looks like you have 3 of them. It's really 1. We just played with the other 2. We played with the algebra there. So this is one of them. You can use this. You can use this. Or you can use that for the cosine.
You take out that 10.3 up top there, bro.
Or 20.3. Trying to get you confused there. And the last one is only one of them for tangent 2 alpha. And that's 2 tangent alpha over what? 1 minus tangent square alpha. Where these come in handy, you'll see in the last section when we start solving trig equations, and one has sine x and one has sine 2x. You couldn't solve a problem that has sine x and sine 2x. So you have to use these identities to replace them because they have to match. So these are double the angles, the 3 of them. That's it. Let's look at some examples here and see if we can go through it and figure things out. Let's try this problem. Just to prove that's really true, but just to show you, let me pick a number to show you the math is actually correct. Let's take 30 degrees, or 60. If I say find sine of 60. Well, isn't 60 2 times 30? So if I want to use double the angle, this is 2 times 30. I can use double the angle. There's an equation for that that says what? Sine 2 alpha is equal to what? 2 times sine alpha cosine alpha. If I apply that here to the right side, alpha is what? 30 degrees? That'll be 2 times sine of 30 cosine 30. Let's do the math. What is sine 30? I'm trying to prove that identity is actually true there. Sine of 30 is 1/2. Sine is the second number. Cosine 30 is the first number. That's what? And what happens to the 2's here? This 2 can cancel this 2, or it doesn't matter which 2. So what's left? Square root of 3 over what? 2. And if you look at this for sine 60, see that? If you go directly to sine 60, what's the answer? Square root of 3 over 2. That's what we just proven. So I found the answer to it, you know. And I can do the same thing with the cosine, the tangent, you know. It's not a big deal. Let me try a few things here. Find, how about we'll do this actually. I like this question. Find sine 2x if what? If cosine x is equal to 4 over 5 and you are in quadrant 1.
Yeah, positive. But anyways.
Yep. I want to find sine 2x. I don't even know what x. I didn't tell you. I said cosine x equals 4 over 5. Well, what is sine 2x equal to? Sine 2x.
2 sine.
Yep.
A.
2 sine x cosine x, right? I go, okay. There's the 2. I know it. What is the sine? I don't know it. What's the cosine? 4 over 5.
We're going to use the other formula.
So I need to find, now for the sine, there's only one for the sine. So I need to find what's sine of x. So I got to look at my table in the first quadrant. Yep. The cosine is the adjacent over the hypotenuse. So this is the 4. That's the 5. Can we find what that side is? Pythagorean's theorem, right? 5 squared equals 4 squared plus y squared. 25 equals 16 plus y squared. Y squared equals to 9. Is y positive or negative?
Positive.
Positive 3. So this side is 3. It has to be 3. Now what is sine of x? Opposite over the hypotenuse. 3 over what? 5. 2 times 3. 6 times 4. 24 over what? 25. over 25. Let's try another one like this, but now I want you to use the calculator there. So get your calculator ready. Find tangent 2x if sine of x equals 0.5 and you are in quadrant 2.
That's radians, right?
Huh?
That's your radians.
Yeah, you always want to be in radian for these. It really doesn't matter because you're going to be finding the tangent. So you could be in degree mode as long as you stay with degree. It could be in tangent. But when you're dealing with a trig in our book, they like to be in radian. So say we are in quadrant 2. Remember, the 0.5 is what?
Positive.
It's a half, right?
Oh, yeah.
You're in quadrant 2. I don't need a calculator for that.
120.
So the sign is what side? Opposite. Remember, 0.5, we said it's 1/2. So this must be 1, that must be 2. To get a 1/2. 1 divided by 2, that's what the 0.5. Can I find what x is? So, Pythagorean's theorem, 2 squared equals what? 1 squared plus x squared. 4 equals 1 plus x squared. X squared equals 3. What's x? Square root 3. Now, is it positive or negative?
Negative.
Negative, because you knew which quadrant.
2.
X is negative here, x is positive on that side of the y-axis. Up, y is positive this way, y is positive, negative down this way. So this is actually minus the square root of 3. Now, do we know from the picture, do we know what tangent theta equal to? Tangent's what? Opposite over the adjacent. What's the opposite? 1 over negative the square root of 3, which they probably don't like it. We have a square root in the bottom. So there's the minus 1 over the square root of 3. If they don't like the square root of 3 in the bottom, what do you do? That's not the answer. That's tangent theta or tangent x. I'm not using they're using x here, right? I shouldn't use x for this.
Isn't sine positive in the
Choose
second
a
quadrant?
Sine is what?
Positive in the second quadrant.
Sine is positive, but the cosine is negative. So positive over negative, the result is negative for the tangent. So I'm looking for tangent 2x. Let's come back here. I know what tangent x is. This is tangent x, not 2x. So to get tangent 2x, it's what? It's 2 times tangent x over what? 1 minus tangent square x. And plug in the numbers. 2 times that number, that's negative 2 the square root of 3 over 3 over 1 minus, and square that number, what do we have? 3 over 9 when you square that one? And 3 over 9 is what? 1/3. Negative 2 the square root of 3 over 3 divided by, what is 1 minus 1/3? 2/3.
Should you be adding the 1/3?
Why?
Negative.
There's the minus sign outside. You take that number and you square it, right?
Yeah, that becomes a positive. The formula
Oh,
has a
oh, I
negative.
Yeah.
didn't see the negative.
Ah, what do you know? Negative 2 the square root of 3 over 2. Can you simplify that?
Yes.
Negative
Square root of 3.
root of 3. Let's see if you can work the problem. Looking at it, if you can figure out what's going on with it. I want to simplify. Simplify I have 4 sine squared x cosine squared x. It says simplify the given expression. Hmm.
Do it twice?
What do you mean do it twice? You might be on the right track. What do you mean by twice? No, you're on the right track.
Because you already have a double angle, but this
Yep.
is times 2.
Can I write this expression? Can I take and write that 2 sine x
Squared?
cosine x, the whole thing squared?
Yeah.
Right?
Yeah.
When you square a 2, what do you have? 4, square the sine, sine square, cosine square. Well, what is that equal to? Let's look on the board. What's sine 2 sine x
2x.
cosine x?
2 sine x.
Sine 2x. So this is equal, I'll put it here. This is equal to sine 2x, the whole thing squared. And we normally, the way we write that, we go sine squared 2x. So I try to match it with what I have on the board. Sine 2 alpha equals 2 sine alpha cosine alpha. Oh, wait a minute. That's sine twice that number. Let me try another one.
That's what I'm hiding.
4 sine 4x cosine 4x. Notice these two are the same. That's good. If I call these two alpha, if I call that alpha, what do you have? You have 4 sine alpha cosine alpha, right? We don't have anything about 4 sine alpha cosine alpha.
Same thing.
Number 14.
Divide by 12.
Number 14.
You can take the 4 and write the 4 as what? 2 times 2.
Yeah.
Isn't that what the 4 is? Now this piece here, equivalent to what?
Sine 2a.
Sine 2 alpha, right? And what's alpha equal to here? In this example, 4x. What's 2 times 4x?
And
2 sine 8x.
that's your answer?
Yep.
Wait, how did we?
Alpha is equal to 4x.
It wasn't that. So this one?
So why is it still 8x?
What's 2 times 4x? 2 alpha.
What do you want it to be?
What do we do with the 2 though on the outside?
Still there.
So it's 2 times sine
Yep,
8x?
2
Okay.
times. Usually write that 2 sine 8x. Just bring it closer. How about this one? It says prove. Prove what? Oh, we already did that. Prove the identity, actually. Let me pick a different one. Oh, we did that too. You know what? Let me, instead of, well, it says, here's the question, is prove. Cosine x minus tangent x sine x, all of that divided by secant x. Nobody asked me the question, where am I going to use the stuff? I don't know. Probably never.
We asked you that last time.
Cosine 2x.
Cosine 2x equals.
Well, remember with the rule when you try to prove or simplify, work with the ugly side. And if you were looking at which side looks the ugly side, the left side, and change everything to what? Sine, cosine. Let's try that. Let's see if that will help us. Cosine x, that's good. Tangent is what? Sine x over cosine x times what? Sine of x. Secant is what? 1 over cosine x. And before I get crazy with it, let me just clean it a little bit there. Cosine x, that's over 1, right? Minus sine squared x over cosine x. Well, if you're going to add or subtract fractions, what do you need?
Common denominator?
Which is what? I'm looking at the top alone even. Just the top. Cosine x, right?
Wait a second.
Cosine x.
Oh,
So that turns to what? Because you want the bottom to be over cosine x, right? So you have to multiply the bottom by what? Cosine x. And if you multiply the bottom by cosine x, you're going to multiply the top by cosine x. What's cosine times cosine? Cosine squared x. Can we make the top as one fraction? The top will be what? The bottom is cosine x. And that's cosine squared x minus sine squared x. Notice that two fractions on the top and the bottom, I can multiply the big fraction, that's the big one. I can multiply the top and the bottom by cosine x.
Wait, when do you do outer over inner?
You can do outer over inner, but in this case, why not cancel them if you can?
Yeah.
Because they will cancel immediately. So what's left? Cosine squared minus sine squared over 1. You don't need the 1. And what's cosine squared minus sine squared? Do we have 1 on the board? Cosine 2x. Voila.
yeah, easy, right?
Piece of cake.
No.
That is number 15. First one, way on the bottom.